Okay, this is problem number 7 from the Linear Algebra Chapter 5 review for the final. And this says to normalize the vectors and construct a 2 by 2 matrix from those columns. So here's two vectors. They're said to be orthogonal, which means their dot product should equal 0. That is, AC plus BD should equal 0 if they're orthogonal. Dotting corresponding elements multiplied and add that together. So to normalize these, we have to divide by the norm of the vectors, or their magnitude. So the magnitude of AB, that is vector AB, its magnitude is the square root of A squared plus B squared. Similarly, the magnitude of vector CD is the square root of C squared plus D squared. So we'll divide each of those vectors by that. So we divide each element by their magnitude. So that will give us the matrix A over the square root of A squared plus B squared, and B over the square root of A squared plus B squared. And the vector CD, in that column we'll get C over the square root of C squared plus D squared, and D over the square root of C squared plus D squared. That would be that magnitude. That would be the two columns of that now a 2 by 2 matrix, which are now the columns are not only orthogonal, they're orthonormal. So when you normalize them, it's an orthonormal set. Each of these has a magnitude of 1. Next it says to select values for A, B, C, and D such that the vectors are still orthogonal and find the determinant of the matrix. So we could pick very simple values for A, B, C, and D. For example, we could let the matrix, we could let A be, if AB was the vector 1, 1, then a perpendicular to that would be like 1, negative 1. Those are perpendicular. And so if we put in 1 for A and B and C and then negative 1 for D, we would get, now the denominator of each of those, this would be 1 squared plus 1 squared, and this would be 1 squared plus negative 1 squared. Those are all going to be the square root of 2. So the new matrix would be 1 over root 2 and 1 over root 2 for matrix, for vector AB. For CD would be 1 over root 2 and negative 1 over root 2. And now we're supposed to find the determinant of that. Well, the determinant of that matrix would be equal to, you cross multiply 1 times 1 root over root 2 times negative 1 over root 2. That's a 1 times negative 1 is negative 1. Root 2 times root 2 is just 2. And then we'll subtract the product of this diagonal, which is 1 times 1, or 1, and root 2 times root 2, which is just 2. So we get negative 1/2 minus 1/2, which is just a negative 1. Now next, if we had picked, we could have selected this to be the first element in that second vector to be a negative. This could have been a negative 1 here and a positive 1 here. That would have made this negative 1 and this positive 1. So this would have been 1 times 1, or positive 1/2, minus 1 times negative 1 would have been a negative 1, and that would make that being plus, that would have given us a positive 1 if we had used negative 1, 1. And the question asks, do you think that the absolute value of the determinant of the matrix formed by the orthonormal set, by this orthonormal set, is always equal to 1? So speculatively, it looks like, well, we got negative 1 and we got 1. So is the absolute value of that determinant always going to be a 1? What if we put in other numbers? What if we put in any numbers? So we might suspect that it is equal to 1. that would be our suspicion. It's equal to 1. Well, or the absolute value of it. So you're going to get a 1 or negative 1 when you take the determinant. So the next video will be a proof of that.